Good evening. My name is Timothy Alexander, and I'm working under Dr. Melchion in the Economics Department, looking at perceptions of opponents' IQ and rational play. To give a little bit of background, I want to start by telling a story. In this story, there's a judge and a prisoner. And the judge passes the following sentence on the prisoner. He says, first, that he's going to execute him one of the next 7 days, and second, he tells him that to make it additionally cruel, the prisoner will not know the day he's going to be executed on. It'll be a complete surprise to him. So the prisoner goes back to his cell and he starts thinking about this. And he reasons that if the judge hasn't killed me by day 6, I would know that he's going to execute me on the 7th day. So it wouldn't be a surprise to me. And therefore, the judge can't kill me on day 7. But, then he reasons, this would mean that if by day 5 he hadn't killed me, I would know he'd have to do it on day 6. And so again, it wouldn't be a surprise, and so he can't kill me on day 6 either. And he continues this reasoning all the way back to arrive at a very strange conclusion. There's no day that the judge can execute him. He's free from execution. So he goes to bed and dreams easily until Wednesday, when he's woken up unexpectedly and executed on the spot. So I tell this story for a couple reasons. First, it shows a model for rational behavior in strategic interactions called subgame perfection, and I'll explain more of what that means in just a moment. But second, it shows that humans don't actually behave according to this model of behavior. And this is why the judge was still able to surprise the prisoner by unexpectedly waking him up on Wednesday. More broadly, our research is looking at the class of strategic interactions. These are interactions where you're thinking strategically about your own choices and assuming that your opponent is doing the same. Examples of this include chess, where you're making the best move assuming your opponent is going to try and counter strategically. A more collaborative example is teamwork, where you might be negotiating with a teammate about how to divide work on a project. You might promise to do one part if they do another. A more sinister example is blackmail, where the victim is deciding whether or not to pay the ransom, and the blackmailer is deciding whether or not to release the sensitive information about the victim. In all of these examples, we can look for something called the subgame perfect equilibrium. And the official definition for this is on the screen. But practically what it means is it's a model for the best possible choice you can make, assuming that you and your opponent will behave rationally and strategically at any possible choice point. So to give an example of this, let's return to blackmail. If we are the victim and we're trying to decide what to do, we could reason the following. If we don't pay the ransom, the blackmailer is simply choosing between releasing the information anyway or not. And they're not getting money in either way. So if you don't pay them, there's no actual incentive for them to follow through on their threat. Now, this is all assuming rational behavior. And as you can imagine, this is a pretty big assumption that is not always true in the real world. And that is what our research is delving into. People don't always actually behave rationally like this model assumes. And this means that people do not actually behave according to this model in the real world. And there are many different factors that play into this. In the blackmail example, there might be a sense of spite. The blackmailer will release the information anyway just to spite the person for not meeting their demands, as a matter of pride. But there are also a lot of other factors. In our research, we're focusing on factors related to how people view their opponent. People use various indicators about their opponent to predict how they're going to play, and this then informs their own choices. The indicator we are going to be investigating is perceived IQ, with our research question being, how does a participant's perception of their opponent's IQ affect their own choices? Now that we've talked about the question we're investigating, let's look at the actual experiment we're going to be running. The experiment will be run in UA's TIDE lab. This is a space the university has to run these types of economic experiments. They recruit students from around the university for a monetary reward, and they then have these workstation setups where participants can interact anonymously with dividers between them. For our treatment groups, there are 3 different ones we'll be considering. The first 2 will be told their opponent's IQ. The first group for when their opponent is high IQ, and the second for when their opponent is low IQ. And then the third group will not be told their opponent's IQ at all. The actual game we'll be investigating is called the centipede game, and it's a common game used to model how closely people follow this model of rational behavior versus not. The way it works is there are two players, the red player and the blue player. And it starts with the red player. The red player is given a simple choice. They can stop or continue. If they stop, the game ends, and they receive the payments that are shown on the screen, 40 coins for them and 10 for their opponent. If they choose to continue, the turn passes to their opponent, who is faced with a similar choice. They can then choose to stop or continue. If they stop, the game again ends, but now the payments have shifted. Each turn, the payments are doubled and are swapped. So now blue is the one receiving the larger pile of 80 coins, and red would only be getting 20. If blue instead chose to continue, it would pass back to red, who would again have a similar choice. And this continues up to a maximum of 6 turns when the game is forced to end. Now, to figure out the best possible choice you can make here, we can use a similar approach as the prisoner did. We can start at the end and work our way backwards. We can reason that if it gets to turn 6, blue is choosing between the two options shown on the screen. And stopping the game at turn 6 earns them twice as much money. So from a rational perspective, they are going to stop if the game gets to turn 6. But red knows this. So this means in turn 5, red has to choose between stopping the game a turn earlier and getting twice as much money, or passing to blue, who will then stop. So it's in red's best interest to stop at turn 5. But blue knows this. So that means in turn 4, it's in blue's best interest to stop, once again, 1 turn earlier to get twice as much money. And we can continue this approach all the way back to the beginning. So it turns out from the subgame perfect equilibrium solution is to end at turn 1. Now, as you can imagine, once again, humans don't actually behave according to this. The following slide shows a graph for when this experiment was done, and it shows the percentage of participants who ended at turn 1, 2, all the way up to 7. And you can see that very few ended at turn 1, with most ending somewhere between turns 2 and 5. Talking now about the long-term research goals for this project. We have 2 different hypotheses. The first is that having a knowledge of their opponent's IQ will affect an individual's choices. And the second is that this effect will be different for individuals who are themselves high versus low IQ. We are stipulating that there will be different motivations for these individuals that will lead to different scopes of the effects. It's important to note here that this experiment has not yet been run. Right now, we are just finished the experimental design portion of the study, so the next steps will be getting IRB approval to run a pilot study, coding the actual experiment, which will be run on the Tide Lab computers, running the experiment, and finally performing data analysis on the results. The long-term goal is that by understanding the role that perception of others has on people's behavior, we can then reverse engineer the process. And we can shape people's behavior in a variety of real-world scenarios simply by changing the way that they view their opponent. Thank you. Are there any questions?
So you were talking about the example of a blackmailer. So a blackmailer might have motivation to uphold their reputation for the future. So how would that affect your experiment?
Definitely, that is an excellent point. That factor of future reputation is a very important one to consider. This concept gets down to something in economics about repeated games versus one-shot games. So in repeated games, there is a motivation to behave a certain way for future interactions. They know they're going to be interacting with this person in the future, so there are motivations to maintain a reputation for, following through on their threats or upholding their promises. A lot of more research has been done in this area of games, however, so our research is focusing on one-shot games. So these are games where the participants are explicitly told that this is a one-time interaction. They're never going to interact with this participant again, and so there's no motivation to uphold reputation or anything of that like. It's only regarding that singular interaction.
So earlier, when you were explaining the experiment, you said that there were 3 other variations. Could you explain what exactly they are and how they're different?
Definitely. I have a slide for that. So the example I showed was a standard 6-turn centipede game. And so the payoffs in those were increasing each turn, and they were increasing exponentially. We're also looking at 2 other variations. The first variation is a constant sum pot. And what this means, if you take a moment to look at the payoffs on the screen, you'll notice that the overall sum of money that the players are receiving is the same as we go along. All that's changing is that the discrepancy in the amounts that each participant gets is increasing. The reason this is important to include is that there's a variety of different factors that can influence people's decision. And one of the large ones that often comes into things is altruism. People emphasizing the common good over just their own good. The beautiful thing about including this game is that because the overall pot is not increasing, there's no motivation for altruistic behavior. And so by including this one as well as the other one, we can separate out what factors and effects are due to altruistic motives versus simply thinking they can outwit their opponent and receive more money. The third game is still an increasing pot, but a linearly increasing pot. The reasoning behind including this one was that one potential downside to the exponentially increasing one is that the beginning amounts of money are so small in comparison to the end amounts participants can receive. And this means that some people may not behave, they don't take the game as seriously at the beginning. And so this will allow us to confirm that that's not a confounding variable we have and allow us to explore the factors we want to more fully.
So a follow-up to that, so you talked about altruism for game 2. Are there any other factors that you're considering?
Definitely. There are several other factors that have been explored in the past. Altruism is one of these. Egalitarianism is somewhat is related but slightly different, where instead of trying to just promote the general good and collective wealth overall, they're trying to emphasize a equality between players. So they would shy away from things that have a large discrepancy in the amounts of players are getting. Quantum response equilibrium is another theory that has been put out there. This sounds complicated. Essentially what it means is that if you assume your opponent is going to behave with certain is going to not behave perfectly rationally, is going to make some mistakes, it's in your best interest to do the same. And the last one is K levels of reasoning simply involves assuming that you can think to a higher depth of reasoning than your opponent. And this is another common model that is used.
Okay. Thank you, Timothy.